Should be working. Why can't I not view my own lives on my phone, bro? Come on. I spent more time fiddling, like doing this live than I have. Do I really have to? Okay. This is unfortunate, but I have to do it. My internet's about to tank. Oof. I've never really actually streamed on this Wi-Fi before, but this is bad. This is bad. Okay. I cannot see my own stream. How am I supposed to do anything if I can't see my own stream? And it doesn't even say I'm live right now. Is this thing even working, bruh? Oh, that's why it's not working, because I'm unlisted. Oh, I'm so stupid. I don't know what I'm searching through. I hope I'm not leaking anything, but whatever. Public. Let's create a new playlist. Competitive road to actually okay, now people should see it. That was really dumb of me. There it is. Alright, is my audio good? Test, test, test. Okay, I think we are ready to go. Alright. I have this open, I have this open, that's all I need. Alright. My mic's unmuted? Can everyone hear me? Alright, we're chilling. Okay. So, some backstory, even though it took 4 minutes for this to get started. Some backstory is that I am trying to get to my school's competitive programming team because our school is one of the best in the nation and it provides a lot of opportunities for jobs. And I really like competitive programming. I also have a bunch of friends that are on it and they keep trying to convince me to do it. So, the goal is in 6 months, we can make JV. So, let's get started. We're doing some CSCS chessboard and queens. And I'm reading, okay, Night Reader, you are fucking up the PDF. And I'm going through the Yusaku guide right now and practicing through that. I have not read the solution for this problem. I did read this just a little bit to get the idea, but I'm going to code it up now. Oh, that's bright. I just got flashbanged. But I am going to go through here and actually code it up. I didn't entirely see the code solution, but I have the idea that I want to go through. So unfortunately, you guys can't see my notebook that I'm writing in to like brainstorm these problems, so I'm sorry. And I'm trying to be a little bit time efficient. Actually, who cares? Ignore this. Okay. Paint is the good friend. And let's make everything black so I can actually see kind of clear. Okay, so right now we're going to use a backtracking solution. And basically the way it works is our backtracking is going to work because we're going to place you're going to try all the solutions. So we're going to place a queen right here originally. And then for this one, we're going to try to place a queen here, then we're going to try to place a queen here, then we're going to try to place a queen here, and then just repeat that for everything. And then if you either go out of bounds or you're in another queen's attack or you're blocked, because if you look at the problem, there's block spots, you return out of the backtrack because you cannot place there. So I have all of that currently set up here in this function where we check out of bounds, the current position, we check if it's an attack or if it's a block. But now I need to actually calculate the attack. And that's going to be easy for something like, if I was like, okay, let me scroll down, boom, 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 boom. Okay, so if I was like right here, this would be easy to, this part is easy to calculate. Obviously, actually let me change the color of that. Obviously, it can't go there, but I'm more concerned about calculating the linear part of it. Because queens can attack in basically like a compass, I guess. I don't know how to say it. But they can attack in these directions. So I actually have to go and calculate it. And, of course, calculating this is easy. Oh, they also can calculate straight up. So, boom, 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 boom. How am I going to do this? Oh, and they also go this way. I forgot. Okay. So we know that if they go straight up or they can go straight down, they go left and right. And then linear from here to here. Change the color of this. And then we can go between this way, this way, this way. And then we have this arrow, this arrow, this arrow, and this arrow. So what I can do is, if it's valid, we are going to set it as a blocked position. I mean, do we have to set it as a blocked position? First, we're going to increment our count because we know we can place it here. Since we can place it here, we're going to go and change around our stuff. So let's calculate. Oh, I want to calculate this. I can run a loop. I need to calculate straight up and straight down. But I do not want to do a load of for loops. So I can start at the top of the column. So let me actually just go and set all of these to block, because I can go to this top of the column. No, let's just call this I or whatever. Let's call this board size plus. So from the top of the board, so because curve board says our length, so this is the row. This is the row we're at, and then we're gonna want to do at the column. We're gonna make this equal to attack, the attack word. So basically, for every position in I, so we're gonna start from the top. We're gonna set this whole column to attack, basically. And we want to do the same thing for the current row we're on. So we can also go and say cur board. I don't like how it doesn't, whatever. Cur board at the row we're on is going to be equal to basically attack times board size. I don't know if I can say that. I don't know, because I don't know in C++ you can say that. Let's just see what alright, let's just see with this logic what happens. Okay, that did not work like I assumed. This is going to be equal to string of board size of attack. Does that work? It does. How much did you print out? 709.28. Okay. It's not close. I mean, wait, that's actually kind of, wait. Oh, oops. Oh wow. Oh, whoa. Oh, okay, whoa. Okay, I'm sorry. I just wanted you to do it one time, but that works too. Whatever. I know it's happening. I'm not gonna print that out again. Okay. So now we have the X, so this handles the Y, and this handles the X. Now we gotta do the diagonal. So what can we say? So we have this part covered, right? Which is we have this part covered. We have this part covered. And we have this part covered. Now we have to do these X's. So I could say, because I just don't want to write like 5 loops. I could have a loop for I could split this up where I have a loop for the top. So like this can be a loop for the top, and then this can be a loop for the bottom. Because at the end of the day, if you look at at this graph, these lines are going to go the same distance. They're going to go the same distance of n, right? And then these are going to go the same distance of n. Because if I have, say I have this grid, if the queen was down here, these actually, no, because here this would go a distance of 2, and then here this would go a distance of 1. I could just do it by the line, though. So, I mean, I could just have one line here, because these are technically this, like, pattern, which that drawing is totally screwed up now. But this pattern right here is just one line. Like, this is one line, and then this is the other line. So I could just run 2 loops for line 1 and then line 2. Oop. Which would work. So I would just need to calculate the starting point, and then we can just go into the end point. And for here, I should need the starting point would be something like this, and then calculate the end point. So if I'm given a coordinate, which this is 1, 1, which is here, the starting point would be zero, 0. I don't know why that took me so long to. I was just thinking. This would be the start, and then the end would be 1, or not 1, 1. It would be 2, 2. But if I place this here, what is my starting point? Because this coordinate plane is 0, 0, 1, 2. This would be 2, 0, 1, 1. So the starting point would be 1, 0. So basically, I think I'm going to take the y, subtract that from the x to get our starting point. Because if I'm here, the starting point would be, because this coordinate plane is 2, 2, this is 0 we start off at. Because all we need is the x that we need to start off at. The y will come with it too. Well, the y is going to be always 0. Well, if I have the queen here, we're at 0, 1. If you try to do that, the starting point is just going to be, if you say 1 minus 0, you're going to get fucking 1, which is not the starting point. Man, I just don't want to have like multiple loops, okay? That's the only reason why it's taking me this long, because I just don't want to have multiple loops. I just want to do it in one line. I mean, calculating the left line, I can just set x minus y. And if it's negative, we know just stay at whatever x we're at. Or if x equals 0, because the goal is to get x to 0, right? If x is equal to 0, we know this is our starting point. We can't do anything about it. At least for this line, right? This line, same thing, right? So once x equals 0, we have our starting point. Here, this would be 1, 2. Starting point is 1, or 0, 1, which is here, which makes sense. And then we just go back. Okay. Let's try it. So we can say int x, y, which is equal to, x is equal to, okay, well, if x is greater than 0, y minus x. Else, you just want to say x. If this is also the case, you also need to reset y. Because y is going to get decremented by however big x is. So if x is 1, this gets decremented by 1. Well, if x is going to be 0, right? Okay. x is going to be 0 no matter what. Now for y is going to be equal to, okay, well we have our column, but x has to be equal to 0. It's always going to be equal to 0 in this case because we're starting from this side. No matter where we go, we will always have x equal to 0 here. So x is just going to be equal to 0, and y is going to be equal to the column we're at is going to be equal to our row minus our column. That makes sense. Because you take our row, which is the y, and then minus it by the column we're at, which is however distance we are from this. So if I'm here, 1, 2, we take the column we're at, which is 1, minus it by the row, which should be give us 1. So our coordinate plane is going to be 1, 1. For now, don't do this. I just want to make sure this is right. I feel like it's right, but let's just run it. Oop. Zero, 0. Let's start off here. Oh, that's a block spot. 0, -1. So it did not work. Because if our column, if it's up here, okay, wait, okay, I need to rethink this now. Is this worth it? I don't know. If column is equal to 0, oh, I'm typing like I'm in Go. If column is equal to 0, x is equal to 0, y is equal to, well, I mean, x is equal to 0 and y is equal to row. You can't do anything about that. Else, if no, because x can't always equal 0. Okay. Alright. 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 I think I'm just going to loop it. I'm spending way too much time doing all this. This is stupid as fuck. Let's just start here, go down, start here, go up. It's that simple. Stop this. Stop this overcomplication. I'm supposed to be doing this fast, okay? I'm supposed to be doing this fast, you know? Speed is key. Alright, so we have our coordinate, which I'm just going to set x, y, x equals c, y is equal to row. Now now we're going to calculate, oh, this is going to be so ugly. So we're going to say actually, we don't even need to do this anymore. This is stupid. So x is equal to our column, while x is less than board size, x plus plus. So this is calculating down. Oh wait, what I could do is I could just say right side, so as x increments. So we're gonna say, why is my indenting fucking up? Okay, thank you. Basically, we're gonna say, let's have an int y1 and an int y2. y1 y2, y1, y2, y1 equals y2, which is equal to the current row we're at. If y1 is less than 0, if y1 is greater than 0, here's what we're going to do. You're going to say cur board at we index it by row, so yes, at y1 is equal to, and then at x is equal to attack. If y2 is less than board size, cur board at y2 x attack. And then of course y2 plus equals 1, y1 minus equals 1. Okay, now do the left side. y1 is equal to y2, which is equal to the row. For int x equals c, x greater than -1, x plus plus. If y1, I can just copy this. It's the same thing. Alright, and now let's just run through this thing. For auto s in cur board. Wow, that was so much simpler. I don't know why I just sat there for like almost like 30 minutes trying to like do some sneaky stuff when I could just done that. Okay, it's taking a little bit. Okay, that was not. Oh, okay. Okay, this is very wrong. Actually, this is still very wrong, but what am I printing out? Stop doing that. It's close. It's very slow though. Okay. First of all, the columns then get set. It's our first issue. Why did that not happen? I thought I had that written. I guess I'm stupid. Cur board at row is equal to string of board size of attack. I thought I had this written. I'm actually so confident that I had this written that I'm actually delusional. Okay. First fix that. Okay. Now the bottom gets calculated right. This needs to be equal to, not equal to, this does not need to be equal to, but this does. The 0 needs to be equal to. And then also this is wrong too. Minus. Okay. Calculated. Wow, that was easy. Let's try doing the middle. If we're in the middle and we get a nice clean thing. Nice. Okay, we want to make sure we don't override it though. Oh wait, it will never get overridden because that position is blocked. So if I try, I need to move over 2 and down by 1. So if I try 6, 5, I should get blocked. I don't get blocked. Why am I not getting blocked? Because what should have happened there is I should have not been able to even go there. I should have just returned out. Because if pause is equal to attack or pause is equal to block, return. Okay, interesting. Interesting. A dot. Do I just have brain damage? 1, 2, 3. Oh yeah, I do. I'm stupid because it's 0 base indexing. No, actually, I'm not stupid. One, 0, 1, 2, 2, 2, 2, 2, 2 should be 1. Okay. Now what is this one? 2, 3, 4, 5, 6. 1, 2, 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. 5 by 5. What board am I inputting? 1, 2, 3, 4, 5, 6, 7, 8. Alright, that seems to be working. I also might want to add a check. I mean, I guess it does the same thing, so it doesn't matter, but I think we should full send now, and let's see if this is gonna do the right thing. And don't print out anymore. Okay, well, it's still printed out, and we got the wrong answer, so that's great. Okay. So we got 209, which is not what it said. It's 65. Let me do something crazy. Are these all different? Okay, they are all different. I don't think this is gonna fix anything, but it won't hurt to try. Because I want to keep my blocks there. 207. And it still overwrit my blocks, which is cool, I guess. Look at it. It just cuts right through it. Why are you doing that? Put that on the diagonal down. If y is greater than 0 and curve board at y1 at x does not equal a block. I feel like this thing is not... This thing is not being very smart. This thing's kind of dumb, I'm not gonna lie. I'm gonna try this for like 6 more minutes to see if I get this working. If not, I'll just go read the solution. There's no point in sitting here forever. Because I've been doing this for like almost an hour, which is really embarrassing. But also, I was like setting up stream and trying to do that. Why is the backtracking not working? This is really weird. I think my vector is breaking. I think I need to send in a copy of this. Because this does not look right. Here, we have this one, right? So we go through like 8 counts of however this could be. I should see another one of this. Maybe let me add a space at the end of this. Maybe it'll be easier to read. Because I feel like clear as rock. Blah blah blah, I don't care. Okay. Okay, that's good. It's not overriding the blocks. It did. Oh, because this is overriding the blocks. Alright. I really don't think this matters, but whatever. Okay, yelled at me? What'd you yell at me for? Oh, I'm not supposed to say if. I'm like in Python or something. So that's how you write it, right? Oh man. Okay, well, it's still being stupid. Okay, I have no idea why this is overriding my block. This makes no sense. Because I feel like we're getting a lot of extra because overriding. What can be doing that? Okay, I'm just going to leave this here. I'm going to leave this here. Oh, going up now. Going up is the same. This is what's happening. Cur board at I at C is equal to, if it does not equal a block, attack else block. Now it should stop. And it's still doing it. It's not doing it actually. Okay, now it's done. So, why am I now getting like 207 of it. So we want to increase the row, right? Because we're at whatever row we're at, we want to be like, okay, go forward. Because here we want to try to do this one. Because this goes straight down through all of this. Let's try to find the... Oh wait, it does override all of it. Again. Wait, no, I'm back at the start, right? Please tell me I'm back at the start. Okay. Now we should figure out why is it not... Oh, because only valid if... It's only valid if... Okay, that was so stupid. It's only valid if we make it through this entire thing, right? Because what I'm saying is if there's 190 spots to place queens, but we're looking for how many spots can we place all 8 queens. That's what we're looking for. So how are we going to know if that's true? Well, we can just say, we can say this. We can make this return an int. If we break because of this, actually, how do I want to do this? Because this, okay. I think I'm gonna return int, and because these cases means we did not place a queen successfully. So these are 0. Else, if we make it through here, we returned 1 queen successfully. But, and we're gonna have a added. Added is equal to the and of this. Okay, I'm being stupid. Guys, how am I gonna calculate this? Let's just have like int added is 0. Added plus equals whatever we get out of here. If added equals 8, we want to say count plus equal. Okay, that did not work at all. That's, oh wait, no, because it didn't compile, that's why. And then this returns 1, which means because we, if you go back up, we originally returned the thing. 0. Nice. Okay. Let's just see. Let's just see. I always accidentally click this thing. Makes me very mad. And then they always try to prompt me with an update. I don't want to update, bro. Okay. I don't see any... Okay. I think this thing is really boned. I'm not even gonna lie to you guys. I think this thing is boned. Like mad boned. Well, added's equal to 1 technically, because we already added the original. Wait, what if I just... Okay, this is gonna seem a little crazy, but if I have this... Right? Place is equal to place plus 1. Get rid of this. Okay. Oops. Whoa, what'd I do? The fuck? Okay. So we're adding all the new ones. Don't do this anymore. Just play. Place. Don't overdo this anymore. don't do this anymore. Place. If place is greater than 8, count plus equals 1, return. So that means if we've placed 8, we're done. And we want to start off with 0 placed. Oh my gosh, bro. Can I just like actually click on stuff? Okay. So this is bro, this is terribly wrong too. I have no idea why I'm so dumb. 6, 8. Does this ever reach past 8? Because my goal is 88. But we have 65. None of them place past 8. How does that make any sense? Whatever, I think I'm wasting my time, and I think we should look at the solution. Okay. Zeros and ones, that's smart too. I should have done that, to be honest, but it's whatever. Okay. Search queens. Wow. Okay, first of all, 45 lines of code. Mine's at 68. Let's start with the main function. For row r less than diameter r plus plus string. Take in the string, and then you're going to loop over the x blocked is equal to row C. That's stupid. Search queens, valid num. Diagonal 1, diagonal 2. If C is equal to diameter, which means our x has reached to the end, we can increment valid num. That's what you do is you go through the row. This is dumb as fuck. Can I just do this in Python, or would I run out of runtime? What's the runtime on this? Eight by 8, 64. Backtracking that is like, okay, huge as fuck. If I could write this in Python, if I could write this in Python, this is cake. Whatever. What am I looking at? Stop. Okay, I do need to go back to this problem. But I'm going to take a break from it and head back to it later. This is grid paths. Oh, pruning. Okay. This one requires us to prune. 49 space grid. Okay, so there are blah 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 times 7 from the upper left to the lower left square. Each path corresponds with a 48 character description containing of down, up, left, right. You are given a description of the path, and which may also contain question mark. So action any direction. Your task is to calculate the number of paths that match the description. What? That just match this? Well, this is stupid. What do you mean match the description? Isn't there only really one path that matches the description? Because you're forced to go down on the first one. Okay, I want to read this, but I don't want them to give me the solution if I read this. I just want to because this is like a topic, but I want to do this problem. I think I should, let me try doing this problem for a bit, and then I'll just read that, because I bet you like $100 that they're probably going to have the solution in there. Alright. Chessboard queens, you've defeated me for now. Grid paths, here I come. Okay. I just don't understand, because how many number of paths that match the description? My thing is isn't there only really one? Because you have to go down, right, up, right, down, blah, 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 blah. No matter what. So it's there should be only one that matches this entire thing. There are, eight. This makes sense. From the upper left square to the lower left square. Each path corresponds to a 48 character description. Each path. Corresponds to the description. You are given a description of a path, which may also contain any description. Your task is to calculate a number of paths that match the description. Well, okay, well, first, I have 4 options. 1, 2, 3, 4, 5, 6, 7. Okay, well, that's way too many options. I'm just not understanding this question because I'm dumb as fuck. So I'm assuming it has to be a path that goes to the end and also that matches this character, and these 2 characters, and this character. because it doesn't make sense, like, if you're just giving question marks, to, like, match it to this. I think, so, like, I'm assuming it's just giving you some of the characters, and you have to match it. You have to see how many reach the end, but also have this, or whatever. Which, that makes sense. Because originally you only have, like, probably, you have this many, but then now also you have to have these two be included too. Which makes a lot of sense. So I'm just going to go and assume that's the case. And if I'm wrong, I'm going to be very sad. So, script, cn, script. Now, that's the only thing I'm taking in. Let's go here, input, bam. Change this to grid paths. Okay, so now we have this. Search and count. Count. So at the end, cout, count, endline, sure. Actually, don't endline because I don't like it. Now, we'll have, so my idea here is what we're going to do is we're going to have, you can go away now. You guys are going to get flashbang, so watch out. Damn, bright as fuck. Okay, here we go. So my idea here is that, like, let's just say we have this. Question mark, question mark, question mark, X. Oh, wait, what the fuck am I doing? Down. Oops. That's just terrible. Oop. Oh, wow. Oh, I should stop. How about this? Okay, so we have like this. If we see, we'll have an I. If we see at this current I, if this is a question mark, then we can just keep going. However, if at I, whatever we picked does not, like, equal, like this, and it's not I, we're gonna escape out. And if our final, if our, like, XY does not equal 0, 8, or whatever it is, 07, it's 7, 0, 7. So, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so the goal is to make it to 1, 7. Okay, so X, Y, I. Alright, here, I'll have this here. Int I. Okay, so if, first of all, the first thing we want to say is if I, okay, so the length is 7 because our we're going to be 0 base. So if I is greater or equal to length, return. Actually, wait. If I is equal to length, string, or we actually don't want a string up here. This dude. There's no way this dude is here. Who is this? This dude. How do I insert an internal? Fuck, I can't read. An internal video? You're distracting me from my problem, but I'll let you go. Video tag. Oop. Video tag. Source is equal to. Do I have a video I can take? These are all screenshots. Don't play that, please. That'd be terrible. v. I name this v. v.mp4. Control. Pretty sure I can say like muted. Now if I video, or what am I doing? And there it is. Don't play though, but there's your video. Do you understand? Okay, so if I is equal to length, we increase our count because we've made it through the entire thing. However, if how do I want to do this? Oh, thanks for the subscriber. How do I want to do this? Do I want to randomly select one, or do I want to... Because if I'm forced to select, like, a choice. If I'm forced to select a choice, like here, like say I'm on this. I'll just say I'll force it. So, let's have a string called path. So if path, if like, oh, we're gonna need to do this string called a script, and don't do that here. So if script yes, I did gain one more subscriber. I want whoever subscribed. I'm blessed. So if this does not equal a question mark, then we want to append it to our path, because we're forced to do that. We also need to like actually like okay, how do I want to structure this? So this is fine, but I want to select, we also have to check if x is greater or equal to, or if x is less than 0, or x is greater than length. Well, because x and y are 1 base, so if x is less than 1, actually I would just make this 0 based. Why not? Go back to the problem. 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. Yeah, that's if it's less than 0, or x is greater than or equal to length, or y is less than 0, or y is greater than or equal to length. Because this is 0 based. We're gonna return. Then we check this means we made it. And then we can now actually run the calculation. So I just don't know if I want to do it in the recursive call or if I want to do it right here. Because if I do it in the recursive call, that'd be a lot easier. Let me have a string choices, or string choice. Let's call it C. We can go, what can we do? Down, up, left, right. Okay. Now, what we're gonna say is, we're gonna run, I think we should run Okay, because if I don't run it, I'm going to have to do the previous. See, I'm not in a competition right now, so I can take time to think about this. Because my thing is, like, I can be given, like, at I mean, if I index I to negative, that's just going to complicate things. But, like, it also if I don't do that, it also complicates the search. Okay, I think I'm just gonna do this. Switch. We're gonna switch the path at I. Fuck. Yeah, let me think about it later. So let me just keep going, actually. Let me keep cooking. So if the description at I does not equal a question mark, we want to append that to our path. Whatever it's at there. Else, what we want to say, and then we want to, here, I'll just run this. Oh, well, actually, let me just put that in an else. Else, and then let's run search on I plus 1, whatever x, y is. And then our path. Else, what we want to do is for int I equals 0, I less than 4, or c dot size. Is it c dot size or c dot length? How do you get the length of a string? That's not. Oh. Oh, and my computer just turned off. Okay, well, I guess I'm not gonna figure out. Tell me the function. Okay, thank you. That's all I wanted to know. Damn. I'm just gonna do dot size. Okay. Then we're gonna run a search on I plus 1, x, y, path plus c at I. Okay. And now, because of the way I have it structured, like with this would make the most sense to do the calculation when you enter the call, but we're gonna have to handle the. Okay, so if I equals 0, if I is greater than 0, then we can do the calculation. How about that? That's simple. Don't know why I'm overcomplicating it. Switch. Switch, I like blanked out for a second. Switch path at I minus 1. Case it's a D. Break, but you want to Y minus equals 1. Case it's a up. You want to say Y plus equals 1. And if it's a left, and if it's a right, you want to increment. So basically, if x does not equal 0, so like if we actually have something that exists in this path, we can grab the top of it and do this calculation and then go down. So let's run the search. Great. I already have an error. My switch statement's wrong. Do I not know how to write? Oh. What does that say? It crashed. Oh, God. Okay. Well, that's cool. Oh, because I'm doing this. $4096. Okay. Okay. I guess I just don't understand the problem then. Unfortunate. Am I stupid or do I just not understand the problem? Which, I mean, that's both. If we don't have a choice, just run through all the possibilities. Do this calculation. Run this to make sure we don't go out of bounds. If we're equal to length. Oh. And. Okay. If we're going. Okay. This is wrong. That's why. If we're equal to length, we're going to check. I'll just add a ternary right here. Who cares? If x is equal to 0 and y is equal to length minus 1, then increment by 1, else don't increment at all. That should work. No, it fucking didn't. What? What do you mean nothing? Length. What does length say? Oh, I. Oh, no. This is all wrong. No. Size. If. Oh, yeah, holy shit. This is all wrong. This is right. This is right. That was wrong as hell. And now count plus equals. If x is equal to 0 and y is equal to length minus 1, then 1, 0. Which basically this means the endpoint, right? Because we said the input. Okay. Still 0. Still 0. This is a question mark, and then this is a comma. Okay, now it's taking a second because it's actually like doing calculations. This is actually taking a really long time. I'm starting to get concerned with how long this is taking. Okay. It's been over a second, and I only have a second to run this. Okay. Oh, wow. Yeah. If it's still running, I fucked up. Okay, I fucked up. Like, really badly. What the fuck? just see out the path. Wow. This is taking a long time. How am I supposed to do this in a second? What the fuck? I guess I am not pruning right at all. Do I even understand what is happening? Because this is not a second, like, calculation. I don't think I understand the problem. Because this is a lot of calculating. Like, I thought I was pruning this right. Damn, I'm stupid. Okay. How the fuck am I gonna know if they're symmetric? That's a stupid ass optimization. That's dumb as fuck. I don't like that. That's really dumb. Okay, wow. Okay, so this is actually like way harder than I thought to make this run fast enough. I did not even. Okay, wow. I did not even. Oh, wow. I'm just dumb as fuck. I did not even think of these possibilities. How am I gonna know if it's symmetric? This one makes sense. I don't understand this one. Like, I'm gonna be straight up. I don't understand this one. But I do understand this one. This one makes sense. This makes sense because you're forced to either go here or here, and you're not going to end up there. But that's only the case if you hit any wall, actually. Because here, if you split, here you'll split, here you'll split, here you'll split. This optimization makes sense. This makes sense too. In the middle. So you're just generating, this is just a prefix sum here. And then you can add 6 and 9. Okay. Okay. Alright, I think I'm gonna hold off on this one, because I'm not a chat at pruning yet. That's crazy. I want to solve. I need to solve. I need to solve chessboard kings and queen, or chessboard queens before I solve grid pass. I can only have. I can have 1,000 queries. See, I don't have, okay, so this is consider an infinite string that consists of all positive integers in decreasing order. Your task is to process Q queries of the form, which is K represents at position K in the string. This is one index space. One index space. So 1 will be the first digit. One, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, 1, 2, 1, 3. Okay, so this is just a pattern finding one. This is just a pattern finding one. I could actually do this right now, I think. So 3 is going to be 7. Why the fuck is... Oh, this is 3 test cases. Okay. 19 is 4. Well, 19 mod... Can we mod this? Because each technically is 9. 19 mod... That is not going to be correct. That's 1, right? That's not right. This is going to be 7, right? So the first 10. $19. Well, 19. Alright, well, no, that's not even true. Never mind. There's 28 characters in this. Well, no, there's actually only... Wait, well, each like, basically 9 digits, you're gonna increase by 2. Right? Because it's gonna grow by 2. Because here, it's 1. So it's 9. The first segment is 9. Well, here now, to get to, like, 19, it's going to be 2 times this length. And then here it's going to be another 2. This is basically like a binary. Because this is... With 2 to the power of 1 is 2. This is 2 to the power of 0. 2 to the power of 1. Then 2 to the... No, because this is still 2 to the power of 2. So every one... Not 10th, because 10th... Because we're really looking for when this digit increases. It's every times 10, it increases by 2. I actually have to write this in my notebook. Okay. Well, 19, the first 9 digits is here. So you're left with 10 now. 4, 6, 8, 10. So this is where 19 would give you. Fuck, bro, stop. where 19 would leave you. What the fuck?
This is terrible.
This is terrible. How am I gonna make it, bro? I only have 6 months and I can't even solve this stupid ass question. Digit queries. Considering that this thing's infinite, it has to be a pattern. But what is the pattern? We know we can minus 10 from the front. I mean, we could mod by 10. Well, like, modding doesn't do anything. It's 10 mod 9 is what? 1? It's actually 9. So we know we're 9 deep into this. And then when you have 9, since we're 9 deep in here, we can mod by whatever base this is, which is 2. But that gives you 1. Because you're 1 away from 18, so that would make sense. Because you would think, like, okay, well, we can mod by this to bring it down to this base, right? Which means we're here now. However, one set of this is like 100. Because not everything's multiplied by 2. Well, 9 divided by 2 is 4. So if I say, like, say you do 19, right? First thing you do is you mod that by 10, which gives you 2, which tells you the base you're in, right? So you take 19, mod it by 10, you get 9. Actually, I lied because I'm stupid. That's 9, right? Well, the 10 gets rid of the first, initial values. I mean, I guess I could do 19 minus 10, but that's not fun. Because 12 mod 10 is 2. No, what the hell? Don't ask for my location. What's wrong with you, Google? Hell. 2. If I were to query 100, what's 100 mod 10? 0. So mod does not help here. I would just have to minus, to be honest. So minus 10 to get rid of the first options. And if you're still greater than 99, because you have 99 options from here, like in reality, because now of the first, what am I talking about? And I can't like go and like manually calculate this because this is 10 to the 18, so that's not gonna take a second. It's gonna take like probably like 2 point something. So I can't go calculate it manually, but I can find the pattern. It's in this like increment thing right here. If there was a 1 front, you have to have 9 to increment. If you do that 9 times, right? If you start at 1 and then you can go to 0 to 9 to get this up by 1 to go to 2. That's 9 to the power of 9, I'm pretty sure. Well, it's not 9 to the power of 9. It's 9 to the power of... It's 9 times... 10, because you can go 90 from here, right? So 11, 12, 13, 14, 15, 16, blah, blah, blah. What the fuck was I thinking? 9 to the power of 9. That's like 729. So that's 9 times 10. Because you have 9 digits that you need to do 10 times. Or you have to go up by 9 10 times in order to get to 100. Which that's just basic math. Like, duh. If you're at 100, to go up by 1, you need to do 9 times 100. So now you need to do 900 operations. So what we can do is... I know this is very boring because I'm not like drawing it out, but like I have no choice right now. And I'm not trying to be entertaining, I'm more trying to grind but also document this process. So I'm sorry, because this was not a very productive practice. And I really want I really want to live stream my practices, but if they're not productive, because I'm being stupid, I'm not going to be able to do it. So I actually want to get a problem done today. So 9 times 100 is 900. So every time, go up. But why does that matter? Right? Because none of this matters. Seven, right? 7. Why? I guess I can calculate all that, but why does that matter? Why does that pattern matter? You start off with 9, then 99, then, or not 99, 90, and then 900, then 9,000, and then it keeps going. Is she like... One, two, three, four, five, six, 9. Then you're here. Like, this is easy, right? The first 9 queries will give you this. Now, any query after that up to the first 9 queries will give you this. That's like the base we're in, right? First 9 queries will give you whatever you asked for. Well, now past here, at least for a long time, just look at this set, for example. If you were to put 9 here, you would get half of that, whatever half that is, which is 4, right? 1, 2, 3, 4, 5, 6. I can't count. 1, 2. It would be 1 right here. because the first 9, since it's odd, just give you whatever the leading digit is where we're at. Because 19 gives me 4 though. So and it also kind of turns into a 0 based string. Am I supposed to show this? I don't even know if I'm supposed to show this stuff.